Okay, so now we will solve the problems on the static friction. So this is the first problem given. The question is determine the frictional force developed on the block as shown in the figure when the force P, which is acting on the block, is 40 Newton, and second condition is it is 80 Newton. Okay, and two values of coefficient of frictions are given. One is a static friction 0.3 and the kinetic friction 0.25. So whenever you solve the problem on the friction, so in the friction we have different types of problem. So out of that first type, it is the block friction. Okay, the meaning of block friction is object will be a block. Okay, second friction we have, it is the wedge friction. So object will be a wedge shape object. So wedge shape means like this. Okay, and third we have the ladder friction. So the ladder friction means object will look like as a rod. Okay, so in your syllabus we have these three types of problem on the friction. So now we will discussing about the block friction. Okay, now refer the problem. We have to find out the frictional force developed on the block. So your first step will be we have to draw the free body diagram. Okay, and for the free body diagram, when we decide the direction of frictional force, we have to observe the direction of motion, that is called as a impending motion. Okay, so just observe in the diagram as the force P, so this is the direction of force P. Okay, so definitely this object will have the tendency to slide on the right side. Okay, so this is the impending motion, this arrow. So I will draw the free body diagram. So this is the force P acting on the block, and its angle is given with respect to x-axis. Then the weight of the object is 100 Newton. So weight will act in the downward direction. So this is 100 Newton. Then at this point, we have the normal reaction. So this reaction will be exactly perpendicular to this contact surface. So this is the N. This is force P. Now because of force P, object has a tendency to slide on the right side. So this direction is the direction of impending motion. So the meaning of impending motion is if there is a possibility of the motion, okay, then object will slide on the right side. That is called as the impending motion. So frictional force always act in the opposite direction to the impending motion. So we will show the frictional force like this. And this frictional force, just we assume this to be F. Okay. So right now we will not consider this as a F max, because here we have to find out amount of frictional force. So the frictional force, it will be less than F max or it may be equal to F max. So that depends on how much force, that is the external force, we are applying on the object. Okay. So now we will resolve this force P along x and y direction. So we know this angle is 30 degree. So this is the x component and this is the y component. So x component will be P cos 30 and y component is P sin 30. Okay. So we have shown all the forces, that is external forces, normal reaction and the frictional force. We have to find out this frictional force. Okay, that surface will offer to this object. So by using the conditions of equilibrium, So in the condition of equilibrium, we will use summation fx0, and second condition will be summation fy0. So for summation fx0, this is x component p cos 30. Then next we have the force F on the negative side. So minus F. Your reference axis will be like this. This is your x axis and this is the y axis. So this is equal to 0. Okay. Then use summation F1. So for summation F1, this is normal reaction, positive, 100 negative, so minus 100. And here y component p sine 30, it is also negative. This is equal to 0. Okay. Now in the question, the force P is given, which is equal to 40 Newton. This is the first case. So here, put the value of P as a 40 Newton. So you will get the value of N. This is equal to 100 plus 40 sine 30. Okay. So this is 1 by 2. This is 20 and 120. So N, that is a normal reaction. This is equal to 120 Newton. Okay. Now from this equation, you can directly find out the value of F, which is equal to P cos 30. So force P is 40. So P cos 30. So this is 40 into cos 30. So this is equal to 34.64. Okay, so your answer is this value. So frictional force developed at the surface when P is equal to 40 Newton. So that frictional force will be F is equal to, or I will write here, F friction, this is equal to 34.64 Newton. Okay, now we have to decide. Actually, this question is not given. But suppose if you want to find out, object will remain in the static condition or it will start its motion. That means object is in static condition or it is in dynamic condition. We have to refer this value. Okay. So from this value, you can find out what is the maximum frictional force that this surface can offer. Okay. So that maximum frictional force we can find out. So maximum frictional force surface can offer. So this is the limiting condition. F max, this is equal to mu s into normal reaction. Okay. So this much force this surface can offer. So mu s is 0.3 into normal reaction. This is equal to 120 Newton. So this is equal to 36 Newton. So surface has capacity to offer frictional force which is equal to 36 Newton. Okay, so now observe, when we apply P force which is equal to 40 Newton, we get the frictional force which is equal to 34.64 Newton. Okay, and this force, it is less than the maximum capacity, which is equal to 36 Newton. Okay, and therefore we can say the given object will remain in equilibrium or in the static condition. So when the object will start its motion, if the required force to keep the object is in equilibrium, if it is greater than the maximum condition, F max, suppose F is greater than 36 Newton, then object will not remain in the static condition. Okay, so it will enter into dynamic condition and it will start moving. Okay, so observe the second condition. So what is given? Second condition is 80 Newton. Okay, so at the 80 Newton, we have to find out the frictional force, and then we have to decide the object will remain in static condition or it is in the dynamic condition. So when force is 80, that is the P is 80 Newton, we will find out the frictional force. So again, observe the free body diagram. So this is 100 Newton. So this is equal to P cos 30. This is P sin 30. This is normal reaction. And this is the frictional force. So from summation Fx 0 and from summation Fy 0. Okay. So from summation Fx, we get the normal reaction. This is equal to 100 plus P sin 30. From summation Fy, so this is for summation Fy. Summation Fx0, you will get the equation as F is equal to P cos 30. I have directly written this value. So P is equal, F is equal to P cos 30. Okay. So F is equal to P is 80 Newton into cos 30. So this is equal to 69.28 Newton. That means when we apply the force P, which is equal to 80 Newton, and suppose we want object to be stationary or in the static condition, surface must offer frictional force which is equal to 69.28 Newton. Okay. At this condition, we will find out what is the maximum frictional force surface can offer. Okay. So for that, we need to find out again normal reaction. So here, if you put the value of P as 80, so you will get the normal reaction which is equal to 140 Newton. Okay, just observe frictional force, maximum frictional force, it will not remain same as that of the previous case because F max depends upon this value, normal reaction. Okay, and therefore when we change the force P value, normal reaction will change, so it becomes 140 Newton. Now find out the maximum force that surface can offer, which is equal to mu s into normal reaction. So this is equal to 0.3 into 140, and this value, this is 42 Newton. Okay, that means surface can offer maximum frictional force 42 Newton. But what is required force to keep it in equilibrium? So this is the required frictional force. This is the required frictional force. Okay, and therefore, as required frictional force, which is the F, it is less than, sorry, it is greater than F max value, that is a maximum or limiting frictional force. Therefore, object will not remain in the static condition. Okay, so as the object is not in the static condition, that means it is continuously moving, which is a dynamic condition. Okay, and therefore, if you want to find out the frictional force at this dynamic condition, then we have to use the kinetic coefficient of friction. So as the object is in dynamic condition, and therefore to get the frictional force at the contact surface, this is the frictional force, which is equal to mu k into normal reaction. Okay, because when we apply that 80 Newton on the object, then this object, it will start motion. So it is continuously moving. Okay, and therefore at this point, the frictional force, it will not be the maximum frictional force, it will become mu k value. Sorry, it will become fk, and this is equal to mu k into normal reaction. Okay, and this frictional force will be the coefficient of kinetic friction is given, which is equal to 0.25 into normal reaction is 140. So this becomes 35 Newton. So this is the frictional force when the force applied is 80 Newton. Okay, so here we have to decide for the given force whether the condition is static or it is a dynamic condition, and depending on that we have to use the proper coefficient. Okay, so this is how you can find out the frictional force at the contact surface for given external force P.